Alrighty. Mentally math!
Let's get mental!
Okay, good job, people.
That's good.
Yeah.
Okay, and, well, it's not like you ever say anything inappropriate usually in class, but just remember, we're recording this and, someone's parent might be listening to it, so, just try to keep it professional here. Oh, the lesson. So why don't you get started? There are a couple people missing in the first class, and we're going to have a thing with vacations where, people are gone for maybe a couple of weeks. And so I should maybe get into a distance learning thing going on, and this is just kind of a test for that. And it'll help out the people that weren't here today. Alrighty. So I'm sure that gave you time to get out ahead of me. And so looking at this, okay, so we could say this is like $7.20 plus 18 cents is the way we could visualize that, giving us $7.38. Then the next one is just divided by 100. So it's really just a couple of boinkies. Boinky, boinky. Put a 0. 0.0. So that would be 36 thousandths. Then, looking at our equivalent fractions, 4/8 is the same as, if we simplified that, what would that be? 1/2. Thanks for the one person. So looking at our equivalent fractions here, that would make this 10/20. And hope everyone noticed this word, estimation. Really? You were trying to do that in your head? It's so funny it's so funny how that gets missed. Here, maybe if I put that down, it'll be easier for some people to see. Okay, so yeah, this is really just 5 times 2 equals 10. Ta-da! I know, you gotta look for it. You gotta look for that. It has gotten me once or twice. Alright, so this would be 4 plus 8 equals 12. It's alright. It gets some people in every day in every class.
Every time.
Oh no, you guys just racking your brains on it. You're like, I gotta do that with male math. Alright. Okay, so then I know 1/10 of 80 is 8, so 9 times 8 would be 72. Right. Alright, the mode. Oh, which one's the popular one here?
The
78 shows up so much.
He's so popular.
So popular. Right.
Oh, no, he's so
Twice
old.
as popular as anyone else, as far as I'm concerned.
How ironic, you know?
Yeah, that's true.
That's our toad right there. Okay, start with the number of vertices in a quadrilateral. So what they're asking is how many corners are there in a rectangle, essentially. 4. Add the number of years in a decade, 14. Subtract half a dozen would be 8.
Yeah, it'd be 8.
Okay, sorry. Then, cited for sounding so unsure. Then multiply by the number of feet in a yard. Will get you 24. Should we do 24?
There's so many sizes. Whoa!
Okay. Anyway.
Mr. Patrick?
Yep.
Quick question. I forgot about what happens when there's 2 numbers that are in mode?
They're tie?
Tied for
I guess it'd both be the mode. They fight. They have a dance battle, and
both of them is the mode.
I believe so. I'll double check that, but I don't see any other way you do it.
One of them,
Yeah.
you just one of them is just like me and you on the blacktop at 3 o'clock.
Okay. It's funny, but we need to move on here because we have 8 examples. Many of them are rather simple. That's the good news. But like these first 3. So our lesson today, and I guess it might have not been obvious there. Oops. Is about rates, and rates really are mostly, when you think of it, they're like ratios, except for real world situations. You can think of it, and so for these first few, it's just about units. Like you're determining what a unit of something is, and in this case, our unit is the average rate of speed, or the average miles per hour. So in our first situation, Arnold drove 390 miles from Los Angeles to Sacramento in 6 hours. What was the average rate of speed? So really simple, right?
No, as in, I was just going to say that I remember learning this in art.
Yeah.
Oh yeah, these first few ones are pretty reviewy. So I think this first one will just have someone. So how would you do that? How would you get that?
So you divide 390 miles by 6 hours, and you get 65 miles per hour.
Mm-hmm. So to reiterate, but maybe just tell us how to get it. Don't necessarily tell us the answer.
Oh, sorry.
That's all right. Yes.
Are we going to be doing time, rate, and distance questions?
Yeah, a little bit. Yeah.
I also like those in RSM.
These are
Huh?
really fun.
I like those in RSM.
These are really
too.
fun.
Yeah. And these types of problems definitely show up on tests like the CTP. So figuring out how to get units is important, and the answer of how to get it is almost always the same.
No,
Anyway.
it's 36.
Oh, sorry. Yeah. I was trying to hurry up here. Dude, there we go. Anyway, and then okay, so that would yep. Okay, and then that would make that answer work out. Okay, so there's for that. And yes, it is a good idea for us to go through these first ones pretty fast because they're all very similar. All right, so on the 390-mile trip, Arnold's car used 15 gallons of gas. His car averaged how many miles per gallon for the trip? So for this one, I'm just going to ask everyone, how do you get the answer? And everyone can just tell me together because I think at this point it should be pretty obvious. So, hey everyone, how do we get the answer to this? We should divide. Okay, why don't everybody do that real quick, just so I'm not up here by myself. If you're already done, cool. I'll take one deep breath, let you get out ahead of me if you haven't started.
This is evidence. This is very easy.
Yeah. These first few are, and I think they're trying to make a point that all of these types of problems are done kind of the same way. And really, I mean, if you're looking at a problem where it seems like they're asking this kind of question, but you're feeling a little bamboozled. If you just guess and divide the two numbers, 75% of the time you're probably going to be correct. And so then that would be
A lot of
6
times when
those.
I'm doing math, I use distributive property without even knowing it. When I'm doing
Sure.
mental math.
Sure. That's a really cool observation. Right on. So is the answer 26?
Yeah.
No!
Miles per gallon.
Miles per gallon. So that would be an acceptable answer, and a great answer is to take the question and flip it around. So, or restate the question in the answer. So, yeah, his car averaged 26 miles per gallon
I accidentally wrote 26 gallons per mile.
for the trip.
Can I say Arnold's car?
Yeah. Oh, yeah. More information? Sure.
Arnold.
Never hurts.
That's how you
Ar-
Jared?
Gerard.
Oh.
Gerard. No, that isn't Jared. It's Gerard. Gerard. He sounds very popular.
Yeah.
My best friend Gerard is so popular. Okay, so he was paid $480 for 30 hours of work. What was Gerard's hourly rate of pay? And well, I mean, I don't. Okay, So everyone together, tell me how to get the answer for this. Ready? 1, 2, 3. We divide. Okay, see if you can do that faster than me. Huh? Yeah, I don't really care about blurting the answer. I'm assuming everyone can get it at this point, and I'm hoping everyone is going through the motions really quickly to get to do it. So I mostly just I'm fishing for people to tell me how to get the answer to move things along. Ooh, good observation. Good observation. All right, then I could have. Okay. Yeah, that would totally work. So then 6 times 3 is 18 with the 0 on that. But yeah, I could have simplified that by getting rid of the 0 on both of those. That is a very good observation. And then so $16 per hour.
That's actually pretty good pay.
It's just above what the national minimum wage should be, and it's just above what California, which is a very progressive state's minimum wage is. So it's not horrible. I would say, like, if he's a student in high school or college and he's like doing it for pocket money type of thing, some extra groceries, buying some clothes his parents don't want to help him with, because they're too fancy, then that might be cool, but I wouldn't want to try to live on that. Nope. All right, so what is the unit price, of a 24-ounce box of cereal priced at $3.60? So, everyone, tell me how we should get this answer. Ready? 1, 2, 3, we divide! Okay, you get started with that. I'll catch up. Now, I think they're trying to make a point that getting all these sort of unit, answers is you usually divide. Probably how you would see this on something that matters, like the CTP, would be like, well, there's one 24-ounce box of cereal priced at $3.60, but then there's a 20-ounce box of cereal that's priced at $3. Which do you get the best? Which is the best value? And so what you would do is you would get the unit price of both of those and compare them. But in this case, it's just a one. So the first thing you would do is get you do the unit price of each one. For this one, it's just really simple, and they're just asking what the unit price of one thing is.
My dad asked me all those value questions.
Right on. Okie dokie. So this one, remember, if there's no decimal in the divisor, then it's perfectly fine for there to be a decimal in the dividend. You just bring it up. And then, I'm assuming if since most people aren't writing, you're already done. Okay.
Unit price and dividend?
Well, in this case, they're asking, so it's a 24-ounce box. They're wondering what is the price, how much does it cost per ounce?
Okay, good.
Per ounce. The unit is ounces. Whereas in our other ones, a unit was miles per gallon. At this one, it's a little more obvious using the word unit because their unit is an ounce. Which is a bit more appropriate to use the word unit for that than those other ones. But that's essentially what we're doing with the other ones. And, I'll just finish this. So this is mentally mathy because I know 10 times 24 is 240, so I know half of that will get me here. Yes, sir?
I just wanted to say that you kind of, it's a small detail, but you kind of forgot the dollar sign.
Oh, I was gonna save that until I actually did my answer. Yeah, but you're correct. So then my answer would be 15 cents per, and I didn't leave myself much space here, ounce. Per OZ. I mean, per Aussie. Oh, I could just do a little slash here. That would probably be actually better. No, that looks better, and it saves my Aussie's my dog. Aussie's my puppy. There's our Aussie kisses all over my arms here. Hey, he doesn't know any better. Just a puppy.
I have a Mira kiss.
Okay. All right. So, now things are finally going to change up a little bit. Gina wants to know how much she will earn working 40 hours. So, but we know what the unit is. But now we're applying that unit to a rate. So, basically, 40 hours is what we're trying to figure out at $16 per hour. So in this case, we don't divide. We 1, 2, 3 multiply. Okay, still pretty reviewy, right?
Yes.
Okay, all right. Good beans. Okay. Well, we'll get through these fast. Once we get to number 7, then I'll show you what the sort of, I don't know, the new idea here is. And yeah. Anyway. So yeah, I'm just gonna multiply and then add a 0 at the end here. So 24. I guess I could have just started with my 0. 0. Then okay. 24. I bet I could, yes. And then I'll just, $640. Yeah. There's plenty of ways I could have done that. Absolutely. Very simple. Okay. Okay, a little more complicated here, but it's sort of a question of what to do with all the information that you're given. So, yeah? Oh, for number 5, I got $640, or if you were doing a really good answer, it would be Dina earned $640 for working 40 hours. Alright, Linda's car holds 12 gallons of fuel and averages 26 miles per gallon. If she starts a 280-mile trip with a full tank of gas, she is likely to reach our destination. Likely to reach her destination without running out of fuel? What is the information in this that we don't actually use when we're calculating it? Like when we're actually doing out the math, what do we not plug in, Amanda? Nope. What are we just using to it's a yes or no question, right? The answer is either yes or no. Yeah. Is she likely to reach her destination without needing to refuel? Yeah. Well, I don't care about blurting the answer. We're taking this step by step to figure out how to get there, to get to our destination, as it were. But so I'm trying to challenge here of what is kind of the information that you're not actually mathing out in this, like that you're not actually doing like an equation with. You're just using it to tell you whether yes or no. Yeah. Very nice. Yeah. Basically, we're just testing our equation against the 12 gallons. Is our answer going to be less than or more than 12 gallons. Because if our answer is 13 gallons, is she likely to make her destination without needing to refuel?
Yes.
Yes?
No.
Because yes, no, wait, maybe if she pushes for a little while. So yeah. So looking at the equation, looking at what we're doing with these numbers. So 26 miles per gallon. Okay, and the question is, can that get her 280 miles? What should we do to these numbers to tell us whether to get us a number that's either going to be above or below 12? Yeah, basically, what's going to tell us how far she can get with that gas? Do we multiply them? Do we add them together? Do we subtract them? Do we stand on our heads and eat ice cream? What? Yes, very good. Because we want to figure out how many miles you can get with this. So doing this out. Do I need to go any further? I mean, I could, and bring this decimal down, and so then I've got like 200, and I can. Does it matter if this is a 9 or an 8 or 7? Because this question is just a yes or no question. So basically, it will take her 10 gallons to get to her destination. So will 12 gallons get?
No.
Yeah.
12 gallons. Yeah, she'll have one gallon and change left over. Right? So our answer here is yes. Because the question is she likely to reach her destination without needing to refuel? Yeah.
Is there another way to do it?
Oh, I'm sure there's plenty of other ways to do it, but
Why did you say likely?
12 by
Huh?
26.
Yeah.
huh?
12 by 26, and then you get the answer,
Yeah.
but you'll just get a bit more, but you'll find out what you need.
Yeah.
Okay, sure. Either way,
So can you multiply 12 by 26?
sure. In fact, well, you can even look at the book. Did they do it that way instead, or did they do it my way?
They did it that way.
Okay.
Yeah, that's what
Whew,
I did.
got
That's what
lucky,
I did.
but sure. Oh, that's a great observation. Yeah.
26
But I
by
thought
12.
that was wrong, so I just didn't do it.
Oh, okay. Yeah. Well, I guess it was just luck that I did it the Saxon way. What?
No, we didn't do it the Saxon way. The Saxon way multiplied it.
Oh, okay. Then yeah. There we go. Well, then we can. I guess we could redo it with that then. Okay. But for anyone that didn't understand, essentially, I'm trying to determine here how. Whether or not she can make it, and this would be a way of finding out how many gallons it would take to get there. So essentially, get 26 miles per gallon, and So this is my miles per gallon. This is the number of miles I'm going. So this is how many gallons I'm gonna need. Okay, well, then do it the multiplying way? I guess I should redo it the way the book did.
But Mr. Crabtree, why does it say likely when it's either likely?
Oh, I know, right? Will she reach her destination? I don't know. Maybe there's a hill. Maybe there's a mountain going over that we're not anticipating, but, maybe, yeah, anyway, okay, so yeah, we can also do it out like that. So 16. Sorry.
Yeah.
Or how many miles can she get? How many miles can she go with the amount that she has? So at the rate of at the rate of 26 miles per gallon with 12 gallons.
Is number 7 the hard one?
It's not hard. You can actually do it with mental math, but the thing is learning the kind of Saxon. I'll call it the Saxon method, but all right. So then she can get this far.
Mr. Petrie, you are doing a time and rate distance question. Example 8.
Is probably fraud. Yeah. Anyway, so this is how far she could get, probably, assuming that there's not some random mountain she has to go over that she's not calculating for. And so once again, the answer is yes. Okay.
Well, Mr. Petrie, example 7 is a distance rate time question.
Okay. So let's make sure I'm doing this about the way the Saxon people want. And I could so you can do these before she was coming. Okay. And
Yeah.
okay. So now we're going to get into, so you remember when I was talking about how units can actually be used in an equation as and it can sort of count a little bit the same way with some of the ways we do things as a number. So say we're getting the area of this box here in units. So say these are in centimeters. So it's 2 centimeters times 2 centimeters. So we're squaring the number. Right, so it's 2 to the power of 2. But then we're also looking at the unit, and we're basically saying centimeters times centimeters is centimeters squared, which of course will get you to 4 square centimeters, you know. But it actually works to think of it as you're multiplying these times each other the way you would a number. At least you're following some of the same sorts of rules. Well, the same thing kind of can work with cross-canceling goodness with units to do conversions of things. And Saxon likes doing it this way. Buzz likes doing it this way. Khan Academy likes doing it this way. So, Buzz was the online program that we used last year. And so I don't think this is an idea that's going away as far as your education goes. And this is sort of a nice introduction to it, this example, because it's really a simple problem if you just look at it. Because Shelley needs to drive. So we'll solve the problem before we even start this. Shelley needs to drive 180 miles from her home near Fort Worth to Austin. If Shelley begins her drive at 9 o'clock a.m. and averages 60 miles per hour, when can she expect to arrive in Austin? So, I mean, basically what this boils down to is she needs to drive 180 miles. She drives 60 miles per hour. So how many hours will it take? Oh, really? You can all just do it. Right. 1, 2, 3 miles. Right? Because it's 3 units of 60, and it's 180 divided by 60, or 18 divided by 6. I mean, it's really, really mentally mathy. So okay, so that's nice. But this what we're gonna show here will kind of carry over to harder more complicated problems. So kind of thinking of it as 180 miles divided by 60 miles, and then our unit here is an hour. So another way we could look at that is, now I'm actually going to make space for my, so I think they don't do this, but I think it's a little easier to put the /1 under it, because we are talking about cross cancel-y stuff. So yeah, the book basically just does, so the amount of space going, and then for every 1 hour, that's your rate, you're going 60 miles. So I'm gonna add an extra piece that the book doesn't have, just for clarity, and I'm really going to keep doing this because I think this makes this sort of make a bit more sense. So essentially, the whole cross-cancel-y goodness thing also works for units. So we could use the cross-cancel-y goodness to basically go, okay, well, we can cross-cancel-y 60 and make that a 1, 180 and make that a 3, because they divide into each other. However, you also can take the units, and since they're across from each other, you can cross-cancel the units too. Right, okay, bear with me, all right? Because like I said, this idea isn't going away. This is gonna keep happening. And much like how we took the units before, and centimeter times centimeter is, we're just gonna say that's centimeters squared. The cross-canceling rule also works that if we have it set up like this, then we can cross-cancel a unit. Now, what makes that useful is now we essentially have everything cross-canceled down here, and this cross-canceled, so we're left with 3 times 1 is 3, and the only unit we have left is the hour, and so we can bring that, and so then we get our answer of 3 hours. So like I've said, there are certainly simpler ways to get the answer for that, but this is something that's going to be used in trickier problems. Now, when you're setting these up, just spoilers. Now, if you are ever wondering which one should go on top and which one should go on bottom, when you're setting up what I'm multiplying this times the rate, right? And so I'm trying to set this up to do a conversion. What you're thinking about is this: what unit am I trying to get rid of? What unit do I want to have left when I'm done? And what this is asking is, it's asking when, and so actually technically we're just going to use that information to find the time. But what we want to know is how many hours. How many hours is it going to take? And so we have to have it set up so that the hours is on top and the miles is on bottom, because otherwise we can't get rid of the miles and be left with the number of hours. I know. Bear with me. If you're walking out of this one, not at a 3, it's okay. We're just trying to introduce a concept, and this is going to keep coming back, and we'll keep practicing it. But once again, so cross cancel this, Then cross cancel this. And essentially the only thing I'm left with is, well, 3 times 1. I'm still looking at that. Is 3, and the only unit I'm left with is the hours. Okay, so then now I can say 9 a.m. plus 3 hours will get me 12 o'clock. Ta-da!
I learned this in RSM like 2 years ago.
Huh?
I learned this in RSM like 2 years ago.
Okay.
I don't get it.
Well, we'll keep working with it. It's a little tricky to get the first time you see it because it looks a little strange. So we'll just keep practicing it till it becomes intuitive, like with this one. All right, and this one we're also gonna look at in terms of a formula, and then convert that form. You plug in our information that we have into the formula. So Felipe. He sounds very popular too.
Yeah.
My friend Felipe
I got it spelled. No.
is planning a bicycle tour
Oh wow, he's
of the state with some friends. He has lots of friends. And he estimates that he can ride, and then information, 7 hours each day and average, information, 12 miles. Actually, that stresses over to here. Why don't we change our... 12 miles per hour. What? Okay, so that appears to be important. How far can they run each day?
For the 7 hours, you should have, not you should have, but you could have highlighted 7 hours each day.
Okay, yeah.
Because the question is,
How much can he ride each day? Okay, so sort of outlining important information there. All right, and then so what we can think of this as a formula. So we are trying to find out the distance it can go each day, right? And that's going to end up being the rate. How fast are they going?
it goes right times time.
Yeah, times the amount of, and that's our rate's going to be a unit, times the amount of time that they're going.
There's some algebra questions that also apply to this too, like
Okay, so just for starters, just from the outset of just with the information we have, do we know the distance yet?
No.
No, so we'll bring that down as a variable. That's kind of as an unknown. Okay, now do we know the rate?
Yes.
What is the rate?
12 miles per hour.
Okay, and then we are going to do that as 12 miles per 1 hour. Okay, and then that's going to be times how much time? 7 hours. And then I'm going to put what is usually the imaginary /1 under it. The book doesn't do that, but I think that is helpful. And actually, I really didn't need that S here. That's silly, sorry. 7. Yeah, well, it's just, our unit is hours. Okay, so, and now you notice that this was arranged 12 miles per 1 hour, and this is just 7 hours with just nothing under there. So that puts these guys, because what we want here for our answer, do we want hours? No. What do we want to know? We want to know miles. So once again, we can cross cancel those, leaving us with just the miles, And it really just boils down to 12 times 7. And, I mean, yes, you could have just looked at that and gone, oh, that's 12 times 7. Right? But, you know, for the purpose of like that we're building on a method of solving problems, you know, we're starting with simple problems just to sort of show the method. All right, so then, 12 times 7, 84. Okay, so then the answer would be 84 miles. Ooh, what would make that even better? Each. Oh yeah, actually, I like what you're, like the cut of your jib there is. Here, I'll give myself a little bit more space. 84 miles per day would be a reasonable way of writing that. Okay, and I believe I can stop this now.